Hey everyone, welcome to eNotebook. Today we're going to take a look at REST API, what it means, what it does, and how to build one in Java and Python. This is going to be a multi-part series of videos, so feel free to jump in wherever you feel comfortable. To be able to understand the implementation details in these tutorials, you would need to have some understanding of Java servlets or Python basics and definitely JSON. If you need them, we also have tutorials for Java, Python, and JSON. You can find the links in the description below. Let's talk a bit about why we need to use REST APIs. Today, REST API is being touted as the best form of digital communication. This is mainly due to the simplicity of building REST APIs and their incredible versatility. They can be used for anything from web page communication to IoT communication with hardware devices, data dumping from a client to a server, and so on and so forth. It is also incredibly scalable and extremely robust. At the end of this video, you will see how easy it is to actually build a simple API. So to start off, let's talk about communication. Communication can be defined as sending or receiving information or data between two or more parties. Communication in the digital context is of three types: simplex, half duplex, and full duplex. Simplex communication is a one-way form of communication. The best example for this would be this video, where I am able to inform you of these things, but however you are unable to respond to this information. Half-duplex communication is a two-way form of communication. However, in this form of communication, only one party may talk to the other at any given time. The best example for this would be something like a radio or a walkie-talkie. Full-duplex communication is a full two-way communication where both parties can talk to each other simultaneously. The best example for this is a telephone call. When we come to REST API, however, it is something of a hybrid. A REST API works as a request-response system. So that means a client first sends a message to a server, that is the request, and the server sends back some data in the form of a response. At first glance, it seems like half duplex, right? But you have to keep in mind that in this architecture, it is not possible for the server to send a message to the client. It can only respond to a request. It's something of a mix between half duplex and simplex. Now coming to REST. REST stands for Representational State Transfer. Let us take an example to see what happens when we open a web page. When you open a web page using a URL to view an image file, that is a resource on the server will show you, that is the client, the image in some format. This is a representation of that particular resource. So here the current resource state of the server, that is the state of the image file which is stored in the server, will be represented to the client in an understandable format, that is on an application on the client, in this case a browser. So the resource state will remain constant with respect to the clients, and only the representation of the resource will change. That means all the clients will get to see the same image, but depending on the browser, the image may change its characteristics. Now let's talk about what it takes to build a proper REST API. Keep in mind that the rules that follow are more of suggestions and do not have to be implemented except for the first couple. Now let's talk about what it takes to build a proper REST API. Keep in mind that the rules that follow are more of suggestions and do not have to be implemented. REST constraints are design rules that are applied to establish the distinct characteristics of the REST architectural style. There are 6 constraints: the client-server constraint, the stateless constraint, the cache constraint, the uniform interface constraint, the layered system constraint, and the code-on-demand constraint. Of these, only the client-server constraint and the stateless constraint are inbuilt. The client-server constraint requires that a service offer one or more capabilities and listen for requests on these capabilities. This helps establish a fundamental distributed architecture, thereby supporting the independent evolution of the client-side logic and server-side logic. A consumer invokes a capability by sending the corresponding request message, and the service either rejects the request or performs the requested task. What this means is that essentially a client-server architecture has to be established for REST API to work properly. A client has to be independent from the server, and a client has its own set of functions which differ from the server. REST is also stateless. That means the communication between service consumer, that is the client, and the service, the server, must be stateless between requests. Each request from the client to the server must contain all the information necessary to understand that request. It cannot take advantage of any stored context on the server. Session state is kept entirely on the client. If you've ever worked with Java JSPs or servlets, you know what I'm talking about when I say session states. The cache constraint. Response messages from the service to its consumers are explicitly labeled as either cacheable or non-cacheable. This way, the service, the consumer, or one of the intermediary middleware components can cache the response for reuse in later requests. Requests are passed through a cache component which may reuse previous responses to partially or completely eliminate some interactions over the network. This form of elimination can improve efficiency and scalability and can further improve user perceived performance by reducing the average latency during a series of interactions. The uniform interface constraint. The interface constraint states that all services and service consumers with a REST compliant architecture must share a single overarching technical interface. Interface is generally applied using the methods and media types provided by HTTP. So we would use GET and POST methods for request and URI for resources, etc. Implementations are decoupled from the services they provide. This makes it optimized for the common case of the web, but results in an interface that is not optimal for other forms of architectural interaction. There are two other final constraints. The layered system constraint, which essentially means that you should follow the MVT or any such multi-layered architecture, and the code on demand constraint. This says that you should be able to add new code to the client without having to update the server. Both these two constraints, for the most part, are extensions of the previous constraint, so they are not that important. So now let's take a look at an actual REST API that was built in Python. This right here is the entire code for the REST API. As you can see, I have two main functions, that is diff and add. And as you can see here, we have something like a path. Keep in mind this path, the sum and the difference keywords, and two integers, int a and int b, that are defined in the URL. Now to access this REST API, or rather to call this REST API, we need to use a web browser, because this, as I said, is a web service. So here you can see that I've already got the URL ready. It essentially says localhost :5000 because this program is running in my own laptop. And I'm calling the function sum. So now I'm just going to do the addition, and I'm giving it two values, 1 and 2. Let's see what we get back. It says value is 3. Let's try with another input. Let's say something like 10 and 20. Now it says the value is 30. This is all well and good, but what about the second function? The difference function. Diff 10 and 20, and I get back -10. So clearly the program is working. Now this is one way of using this code. But again, you might be thinking to yourself right now, what is the difference between this and a servlet? I can do the same thing with a servlet, or even better, I can do the same thing with JavaScript. You're absolutely right. However, I stated earlier that one of the best things about REST API is its versatility. It can be used almost anywhere. If I take this particular URL and put it in a terminal and use the command called curl, that is curl, with the post method, then voila, I get back the same value. I can give it a different set of numbers and I will still get back a calculated value. Again, I can use the sum function and I will get back a calculated value. So this means that I can consume or use this REST API from a Linux interface. That also means I can use it from almost every language out there. I can use it from JavaScript, I can use it from Java, Python, Perl, or any other language that you are using for your application. This should give you an idea of how versatile a REST API can be. Now, just for fun, I'm going to add a new function called multiply to my little program here. So I'm just going to copy part of the previous code, or actually I'm just going to copy the whole code and modify it. So this app.route here is where we specify our URL format. I'm just going to use the keyword multi instead of diff, here, and I'm going to also change the function name to multiply, save the file, and also of course change the operator from the negative sign to the multiplication sign. And that's pretty much it. So now I should have a new function readily available to me whenever I need it. So my program is running once again on localhost colon 5000. So let's try it out. So URL -x post http ://localhost colon 5000 /multi/10/20. And now we get back a value 200. If I say something like 30,20, I get back 600. So clearly it's accepting my inputs and giving me back a valid response. So that's it for today. If you have any questions, drop a comment. In the future videos, we will be dealing with this particular example, and I will tell you how this works. I will be explaining each part of it. I'll be explaining not just in Python, but also in Java, how to use JAX-RS libraries, how to use the Python Flask libraries, and so on and so forth. So if you like this video, please do like, share, and subscribe.